Yay.
Investigation.
What is this?
If I sit down, does that mean no one can see me?
Yeah.
Hang on, I might like this, and maybe I don't want people to see me, because I've just got off the 5 o'clock train. Maybe I want people to not see me. This is a good thing.
At least they can see the screen.
Yeah.
Very large. So, hello everybody again. Time for our second session. We have 3 papers in this session as well. We're kicking it off with Tom Garner's paper, which Jordanous is presenting. Take it away.
It's easier if I stand up for the streaming as well.
Don't worry about it.
Okay. It makes no difference. I know I'm small, so therefore if I'm standing up or sitting down. Yeah, thank you very much. And also thanks for rearranging the order slightly. I apologise in advance. I missed the morning session because I thought inexplicably that it was a good idea to run a 30-kilometre trail race and then get the 5 a.m. train here this morning. So the quality of the presentation might suffer as a result. I'm hoping not. So this is a paper that Tom and I have put together. Tom Garner is at University of Portsmouth. I'm at University of Kent. My name's Jordanous. We're looking at emergent sound perception, so how the perception of sound emerges from different interacting characteristics, and looking specifically in the context of how non-player characters can perceive sound as it as different aspects of a virtual environment interact. So this work is in very early stages. It's a very new collaboration between myself and Tom. The vast majority of the work in this paper is Tom's, because he comes from a background of sound cognition, cognitive modelling, and then he's become very interested in AI, computational creativity. So that's where we're at. So this is more of a position paper, I suppose, in the paper terms for ICCC. But just to give you an idea of what we're talking about here, this is the Knizer triangle, the visual illusion. We have here perfectly positioned shapes, and we can see that triangle shape emerging. That triangle isn't in any way defined in any kind of physical way, but we see it, the observer sees it. And that kind of emerging perception is what we're looking at in the context of non-player characters. So the context here that we are working within, so people who are using virtual environments more generally, and specifically for our paper here, games, virtual reality, they want the environment to be real. They want it to feel natural. They want to be able to have a responsive environment. And they want to, critically, they want to feel immersed in the environment. They don't want things that will jolt them out of that feeling. But at the moment, the kind of AIs we've looked at so far, they're not so good for this, for non-player characters responding to unexpected events that are generated procedurally. And real-world inputs, so sound would be one. Another one might be inputs from biometrics or from, say, physical inputs. So this is a bit of a problem because actually, if we don't make our non-player character AI a little bit more able to respond in a realistic way, we're not keeping pace with what the gamers want. We're not keeping pace with what's expected. So the solution that Tom and I have been looking at is to use Tom's previous work in perception, sound perception, and mix that in with some machine learning and some ideas from computational creativity to allow non-player characters to be able to respond to these complex environments. And particularly we're looking at sonic environments, we're looking at sound. We're not looking at music, we're not looking at speech. We're focusing in on non-music, non-speech sounds. So, you know, stuff going on. So here's an example. This is where I've got a little bit of sound and I'm hoping my laptop will be able to compete with what's outside, although actually it's adding a nice dimension to my example of hearing sounds in context of other things. Okay. We have a sound wave. What's that representing? Yeah, I know, it's a trick question. So then, there you are, there's the actual, anyone now feeling like they might know what that sound is? Jeremy does. Ooh, almost. There we are. Hey. Very close. So yeah. Okay, so as we get more information from different modalities, we're able to attribute more meaning to that sound that we're perceiving. So we're getting this array of additional information to give us context in which to interpret the sound wave. So now, taking away the video, but you remember the video. So you remember, we just talked about it being coffee. So with that kind of memory recall, we can still attribute meaning to that same sound that we didn't have when we listened to it the first time. Okay? Okay, there's some controversial stuff in this talk. When you work with cognitive scientists, it gets a bit fun. I'm going to present the controversial stuff and then just look innocent. So, a tree falls in the woods. Does it make a sound if there's no one here to hear it? We're going to say no, it doesn't make a sound, because a sound wave must be able to reach a receiver and be perceived to become a sound. So sound is not a sound wave, that's what we're saying. The sound wave is just a component of the sound, it's not the entire sound. And what we hear, our kind of sonic experience, is made up of this huge complex arrangement. So the sound wave, things that we've experienced before, things that we're hearing alongside it, maybe personal, say if you're a musician, you played loads of gigs, you get tinnitus all the time, or you can't hear certain frequencies. We've all got our own individual experiences of hearing sound. And you can hear the same sound, as we've just found out, you can hear the same sound twice and have different experiences based on the experience that you've got at the moment. So for example, some of the things we've been playing around with, if you hear a sound, you might be, say if you're alone and everything's all been particularly very quiet, you're hearing it in a certain way. If you're quite rested, you've been having a picnic and you're relaxed and happy, you hear it in a certain way. Or perhaps if it's a very high decibel sound, that will, when it's previously been very quiet, you have a different reaction. Okay. So this is now where I am presenting Tom's model. So I'm very, very conscious of the fact that Tom will be watching back this video later on, and I'm actually very happy if the live stream's not working. I might get you to edit it later, Mike. This is a model of Sonic Virtuality. It's pretty cool. It comes from Tom Garner's book with Mark Grimshaw, which came out last year. And one thing to say, this is a model of perceiving sound, and it's including a whole array of different things. So the idea is that a person is embodied in a sonic environment, and they're situated in that environment, so they are part of that sonic environment, affecting it themselves. So you have the exosonic components, which are bits in the physical domain. Things like different stimuli, the sound waves, any videos for the coffee cup, say. Acoustic and physiological factors. Perhaps somebody's behaviour at the time, like whether they're sitting very quietly or whether they're very agitated. So that's the exosonic components for this model of how we perceive sound. Endosonic components are components of our psychological domain. They become more individualised. Well, as individualized, I guess. So endosonic components are things like our memories. We recall seeing the video of the coffee cup, and then we remember and associate that video with the sound. Our emotional state, what we believe in, what we're expecting to hear. That's the exosonic and endosonic components of how we're hearing, how we perceive sound, according to this Sonic Virtuality model that's come from Tom Garner's doctoral work and further work. So the sonic aggregate in the Sonic Virtuality model is the combination, the sum total of all these components put together. And Tom's identified the actualization point as the point at which everything's put together to get the emergent perception that you get from hearing that sound at that time. So that might be the sound, any things that you see alongside. So that's the point at which you go, oh yeah, coffee, or water, or whatever else came into your mind when I played that sound for the first time. I hope that was okay, Tom. So the point that I really want to emphasize is that when we're modeling how you perceive sound and how we transfer that into an AI model that we can use in games, we're not just modeling what's happening in the brain, we're modeling this huge array of different elements, and that the way that we perceive sound is diffused across all these different elements, the physical input, stuff happening in the environment, endosonic, that's a personal or psychological components of, in an AI world, the non-player character. So just the same as the Sonic Virtuality model that I presented in the previous slide, it doesn't position perception just in the brain, it's diffused over all these different elements. Equally, if we want to do a computational model of how a non-player character will perceive sound, we don't want to just create an audio perception program as this enclosed system. So it's a bit like if procedural content generation defines the rules that lead to content being generated rather than the content itself. So what we're aiming for is a model of sound perception that defines the elements that determine the perception rather than the perception of the sound itself. So we're not coding up auditory perception. What we're coding up is rules for how a range of different components might behave from which the perception emerges. So from simple rules emerges complex behaviour. And one thing to say is that the actual player in a game is a part of the system. So again, slightly controversially, the AI can't perceive sound unless there is a player there perceiving them perceive it. It's a bit like if the tree falls in the woods no one's there to hear it. Okay. So to put that in a different way, the system that we're talking about, our kind of end goal of this work, it's not intended to process sound wave data and then produce quantitative replications of that. It's for generating non-player character behaviour that human players can perceive and interact with. This is all getting back to the idea of being immersed in the game, but from a sonic angle rather than from a visual angle. Okay. This is early days. We have spent quite a lot of time talking about the more philosophical aspects of this. And so we're moving into a point where we want to make this more tangible, and this workshop is at a perfect time because mostly I'm just here looking for feedback today. And so what we want to do is take those ideas and put it into some kind of computational AI structure. So we've got the game world. This arrangement of nodes is just random. It's to indicate that there's lots of different aspects of things going on here that are all interconnected. But it's supposed to look a little bit like a neural network of some kind. That's the way we're thinking at the moment. So various things going on, various variables or input, and the idea is that things that have happened before affect how the system behaves in the future. So there's some kind of learning going on. So you have stuff in the game world, like the virtual environment, things like what time is it in the game? Is it nighttime in the game? Is the game currently in an indoor environment? What's the NPC's objective at the time? Is there a threat around? Then you have the sounds that players make. As in, I don't know, if you're playing and your mate calls out if you want a cup of tea or not, that might be a sound. But also things like, oh, if something happens that's unexpected. And then getting that processed and represented by the AI model in some kind of physical way. So representing things like whether it might be some kind of vocal thing or gesture. I think we're far more kind of ignoring gesture for the moment. And the idea is that we move towards behaviour nodes. So lots of stuff comes in, gets all mangled up, and out emerges some kind of behaviour like move closer or freeze or move away. This is, again, I should say these are not random, but examples. And the idea is that as more and more data might go through one particular path, very similar to neural networks, that if one path through it becomes more useful, the weights on that get strengthened, so that it learns certain behaviours as more useful over time. Okay. I might jump over this. I think cutting close to 20 minutes on that. I'll go very quickly. So just going back into the theoretical world a little bit. This is an example of an auditory perception theory. This comes from Turi and Irola's modes of listening. So how somebody can listen to a sound wave in multiple different ways. So they might listen in a reflexive way where they immediately respond. They might listen in a kinesthetic way where it forces some kind of physical movement. Might listen with some kind of semantic mode going on, so you're putting meaning into what you hear. So I'll jump over that slide that you can't see anyway, in the interest of time. So what are we actually going to do with this stuff? This is where we're at the moment. This is going to be a proof of concept. It's going to be a 2D top-down game, one human player, one NPC. Very basic. So players can move around this two-dimensional space. They've got move forward, move backwards, Z-axis rotation. And communication is via sound. So the AI can communicate using a limited range of very simple sonic, producing waveforms. Human player, their behaviour is limited as well. And the idea is that the players are reacting to each other's sound. That's the idea. So taking this, putting it into that 2D environment. No predefined behaviours are going into the AI, just these ideas of what do we model and what kind of behaviours might come out will emerge. Can you tell that we haven't done this yet? It's that kind of challenge that you think, yeah, it's going to be great. And now I have to explain how to do it, and we haven't done it yet. So yeah, I'll say that up front. So this is basically a platform from which we're going to experiment and tinker. And where we're kind of thinking of going, and this is a little bit more ambitious, and yeah, further ideas would also be welcome. It's a sonic environment, sonic games, where sound is the main modality that's being used, alongside other modalities, because you get information from those. So, for example, a player is hooked up so that sound can go into the game, and they have to hold their breath if they're hiding in a game. And if they breathe, then the NPC might be able to hear them breathing. And this was quite cool. I think this came up from a student suggestion actually when we talked about it in a lecture. So that the NPCs might be able to creatively use sound. So this example is you're currently hiding in a nearby locker, and the NPC learns from prior analysis of your shrieking that if it bangs at random on nearby objects, you'll probably scream again, and it can use that tactic to try and flush you out by banging on things, and then it can find you and eat you. So this kind of thing, using sound as a behavioural tactic. Or a player might be able to use their own voice to distract the non-player character, but then, of course, we've got learning in the game, so the NPC won't fall for this event all the time. And one idea that's come up when we've discussed this is that we just have the game in total darkness, and the only modality you've got is sound, which would be really, really cool and quite weird. So Tom's done a little bit of investigative work into that. But yeah. So I'm going to finish there. I think the key things that I quite like feedback on mine and Tom's behalf, just suggestions on anything technical, any likely technical challenges that you might have dealt with before or thought about before, any existing work that we haven't come across yet that's quite similar to this, particularly within sort of games and AI, and any ideas on, once we've done all this crazy stuff, how else could we deploy it? How else could we use it? Yeah, I guess I'll stop there. Thank you very much.
On the slide about perceiving, the player perceiving this.
That one.
After that one.
Oh, after that.
Yeah.
That one.
So when you say there's a player perceiving and perceive it, you say a player, you mean a human player or an NPC?
Human player.
So, but NPCs, things should happen in the background, right?
Yeah, but we're not saying things can't happen in the background, but then that means that there's a background and a foreground. So there is a player in the foreground from which you do things in the background to hide them from.
Is that because
That makes sense?
Well, no, it's like if there was like a loud noise that happens downstairs,
Yeah.
we don't hear it here, but the rest of the building does, and then so they all run downstairs. When I leave the room, I should see a bunch of people downstairs crowding around some thing.
But you won't know why, so who cares?
But the world would have.
The world would have changed, yeah, that's true. I think that we're trying to reduce scope a little bit.
Okay. That makes
That's
sense.
completely valid. That stuff, well, yeah, of course, so stuff will happen when you think about the wider aspects of the game. So we're focusing very much on perception of sound. So stuff that's happening as part of gameplay, yeah, for sure. But what we're saying is, this is more of a, there's no point in the NPCs. Yeah.
The other thing I thought of as another application is, thinking about sound as information that takes time to travel. So kind of using the system to model how information passes through an environment.
Ooh.
The time delay could be kind of a pretty useful thing to do in games, like game modeling.
Yeah, that would be fun. Cool, yeah, thank you.
In terms of increasing the scope,
Thanks.
this
We've not got enough to deal with right now.
This seems, I think, which would have a lot of potential for games which break the fourth wall in some sense, in that the AIs respond to unintentional sounds on the side of the kind of player's input, so doors or people shouting at them, or conversations between players and their friends and so forth.
Yeah.
And I think that type of thing, I reminded of the game Tear Away on the PSP, I think, where there's a point where you are kind of asked to put your thumb on the base of the thing, and then it kind of takes photos of your thumb, and then your thumb kind of breaks into the real world, into the game world. And I think something like that, I think that there would be some kind of fourth wall breaky, engaging with what's happening in the player's real world space within the game, something in that, yeah.
Yeah, that's a really cool idea. Yeah, because this is the idea of you can be playing the game and then, oh, Mike, do you want a cup of tea? You know?
Keep playing the game.
It's like, what's going on? What's going on? So I like the idea that at the moment, visual immersion, okay, great, but we don't just have one sense. So if we can crack a few more of those senses, then yeah.
I mean, I think that would make sense for a VR experience. But I had a question for the game design, because it's if it's a scary game, like a stealth game where alien is out to get you, what would stop me from just taking off the headset while I'm doing? Because like you mentioned it later that you can also use your voice for good. If it's only causing you ill, then
Yeah, I guess the thing that would stop you there would be that you're a good gamer and not cheating.
Don't assume it.
But it would be very, very cool if we're not reliant on things like headsets, so that people can't do that. That would be the easiest cheat in the world, wouldn't it? Oh, look, I can say everything. I'll have that cup of tea now, thanks. So Tom's very interested more generally in getting information from the player. So things like galvanic skin response, things like that. So just getting as much input from the physical world as possible. And at the moment, yeah, we'd kind of be relying on sort of crappy headsets and things, but...
Well, the thing is, if you have a VR headset, then you can't really take it off because then you're out of the game completely.
Yeah, that's true, yeah.
I'd like to put the previous comment, but on the other side, what about the balance for someone with, I don't know, mute, who has some difficulty to hold his breath or anything like that?
Yeah, there's certainly, yeah. I think, but at the moment, if somebody has difficulty seeing, people don't adjust the game for them so much, or they have, you know, red and green things that are supposed to mean different things next to each other, and then, you know, colourblind. Yeah. So, yeah, it's a valid point. But I guess by trying to include other senses, we're kind of balancing out the people who can't speak so well against the people who can't see so well. Yeah.
To be fair, I mean, if we were playing this in this building, that would be a challenge.
It would.
That is not due to us, that you're like, because we live in a big city, or if you live with your parents or something.
Yeah, but it makes it, there's another little challenge there, isn't there? So where you play a game suddenly becomes really important. And yeah.
Alone and silent, that's perfect.
Yeah.
We'll have a soundproof room.
Yes.
So one thing that might let you get around the problem of people disengaging is adding in another human player. So there are some multiplayer games where people have to communicate with each other using voice, but rather than that being like a Skype call where it's direct, it's projected in the game as an actual sound. So if you
For people in
talk
different
at a
rooms
normal
and
volume
things.
over the radio, it's also where you're standing, people nearby can hear you. And in multiplayer games that produces a conflict for the players, which could be quite interesting. But I really like, these ideas are really interesting.
Cool. Yeah, we could definitely, in the proof of concept, once we've got this working, I say once we've got this working, yeah, because it's just going to be fine, it's going to be easy, it's going to be fun. Yeah, then sticking another player into that environment and having a little tinker with that will be, yeah, that'll be good.
All right. So, thank you.
Yeah.